everyone. My name is Vera. Welcome to Test Masters Academy Online. It's organized by Global Quality Leadership Institute, a nonprofit organization whose mission is to become the world leading advocate for quality and technology. The organization will reach this goal through developing innovative programs on software testing and quality for the tech community, leadership, and educational institutions. Test Masters Online is our new educational project. It includes the series of free webinars and Ask the Experts roundtables with the renowned speakers in our testing community. It offers new ideas, knowledge, and the opportunity to chat and network with software testers around the world. Our other project is Software Testing Conference Contest NYC on November 14th through 16th in New York. We invite you to discover emergent trends and practices in software testing and quality engineering, lay your hands and eyes on latest technologies, and immerse yourself into the thought leadership of others in 3 unforgettable days at Contest NYC. Our presenters are senior technologists, managers, and practitioners who are the innovators and experts in their field. The conference is held on November 14th through 16th this year in New York. The link to register is in Test Masters Academy Slack chat. Today we have Christin Wiedemann with us, and she will be speaking on the topic of future horizons in testing today. Hello, Christine.
Hello, everyone. Thank you very much for the introduction, and it's my pleasure to be giving this webinar today. And a big thank you to Anna for inviting me. So we're going to talk a little bit about the future of testing. And it's going to be what I think the future of testing will look like in the next decade, in the next 10 years. And of course, we can't predict the future, but we're going to discuss what I think are some underlying trends that hopefully will give us a bit of insight into what we can expect in the next 10 years. And I'm just having a little bit of an issue with Zoom, but there we go. So I wanted to start by quickly introducing myself. So my name is Christin Wiedemann, and I am a particle physicist by training. And I got a Ph.D. in physics from Stockholm University in 2007. And once I graduated, I started working as a developer, and then as a tester, manager, trainer, coach, and mentor. And for the last 3 to 4 years, my focus has been more on management and on the mentoring and test advocacy side. You can find me on Twitter, of course, and also on LinkedIn. And I'm always happy to connect with people. So I wanted to start with a quick little poll. I want to know what you think the future of software testing looks like. So if you go to the link on the top of the slide, paulev.com/KristinWeed379, you can just type in free text fields words that you think describe the future of testing. What are your expectations? What are your hopes? And maybe also, what are your fears? So take a moment to think about, what do you think the future of testing will look like? And of course, if you're having any issues with the poll, let me know. Automation is one of the words, and I think that's what a lot of people think about when we think about the future of testing. Manual, AI, I think. Lots, but also less testing. And that's quite interesting. So we have terms that are completely contradictory. You think there's going to be automation in the future, but also manual testing. You think there's going to be a lot of testing, and you think there's going to be less testing. So I'm going to ask you to answer another poll for me. And that is, what do you think will have the biggest impact on the future of testing? And I give you the options: big data, artificial intelligence, Internet of Things, quantum computing, or blockchains. You can clear your answers and change them if you want to. So we're getting a lot of vote for big data and artificial intelligence, but also quite a few for Internet of Things. So thank you for those results. They map very well my outline and what we're planning on talking about today. So I'm going to talk a little bit about technology trends and conceptual trends. And I'll explain later on what I mean by technology versus conceptual trends. We are going to talk about big data and machine learning, which is one implementation of artificial intelligence. And those are two of the things that you thought are going to have the biggest impact on the future of testing. We're also going to talk about cybersecurity and quantum computing, fragmentation, which was the third thing you picked, Internet of Things, and controls. And when we talk about conceptual trends, we're going to focus on the role of test automation and what new skills tester might need in the future. Because that's really why we're having this discussion today to start with, is technology is continuously evolving. There's so many things happening all the time. There are new devices, new applications, new types of software that we wouldn't even have been able to imagine 5 years ago. And the question, of course, is how is that all going to impact our roles as testers and how we test? And to really be able to understand that, I think we need to look at those trends and see where we think the technology landscape is heading, and try to understand how testing will be impacted. But there's definitely no doubt that testing will have to evolve alongside technology. The big, rapid pace of progress that we're seeing, I don't see that slowing down anytime soon, which means we really need to think about what do we as testers need to learn to be prepared for the future. And I keep saying future all the time, but I think before we go into the future, we need to talk a little bit about the past and the present as well. So we all live here and now, of course, but I think we have very different mindsets. And mentally, we tend to live in slightly different eras. I think there are people that are stuck in the past. They're very much relying on their previous experiences when they decide how to handle new challenges. Other people are more focused on the present, and they use the information they currently have at hand to decide how to deal with different situations. And then there are people that are very forward-looking. They're already in the future, imagining new solutions and trying to use all their creativity and innovativeness to come up with new ideas and new approaches. So is one approach better than the other? I think there's value in all three, but it's a question of how you weigh them. And I definitely think there's a danger in focusing too much on history. Focusing too much on our past experiences, it makes us vulnerable to change. If we look only at challenges we've already encountered, we're not really prepared for new or different problems. And especially in the testing community, we tend to talk a lot about best practices and industry standards. And there are people that strongly argue that there are no best practices, and there are people that will say that, yes, absolutely there are. And these discussions are not new, but I think it's important to keep in mind that a best practice or an industry standard, it's basically a set of instructions for how to handle future events based on the past, so based on our previous experiences. And there is absolutely value in letting history influence how we deal with both the present and the future. That's what's called learning. We learn based on what we've seen before. Where it gets dangerous is when we let that history, our past experiences, narrow our field of vision. So when we let history constrain us. So don't disregard learning, but make sure that you really learn from history rather than be constrained by it. And if you're using a so-called industry standard or a best practice, keep in mind that what it is a tool for how to handle situations that you already know, but it doesn't really prepare you for the future challenges. And that is why we're talking about the future in testing, is to try to prepare for the unknown. So let's look into the future. What skills are we going to need? How do we best prepare? Well, like I said earlier, we can't predict the future, but we can influence it. And what we need to accept is that we are preparing for the unknown. And to be able to prepare for something that we don't know what it is, we need to embrace curiosity, continuous learning, flexibility, and adaptability. We don't know exactly what skills we're going to need in the future, and we don't know exactly how technology is going to evolve. But what we do know is that it will keep evolving, and probably quite rapidly. And that means that more than anything else, we need to focus on our learning. And all of you participating today have, of course, taken one step by being in this webinar. It's part of our continued professional learning. So when we look into the future, I do want to distinguish between technology trends and conceptual trends. They do sometimes overlap, they are coupled, but I still find it valuable to make a distinction. So when I talk about technology trends, I mean tools and devices and applications. An example would be that there are now smart home devices like thermostats or even locks that you can control from your smartphone. When I talk about conceptual trends, I talk about the evolution of ideas. So one example would be that there's been a move to having dedicated testers on team, whereas in the past, testing was done by the developers. And to me, that's a conceptual trend. So we're going to start looking at the technology trends. And we are going to talk about big data, machine learning, but also cybersecurity, quantum computing, fragmentation, Internet of Things, and controls. So what is big data? The term big data has actually been in use since the 1990s, but the definition or the threshold for what counts as big data keeps moving. And what we thought of as big data in 1990 is not considered big data necessarily anymore. And it's hard to pick one definition, but the one that I find to be the most useful is that big data is data sets that are larger what you can handle by common software tools. So if you can't do an analysis of the data on your laptop at home because the data set is too big, then maybe it counts as a big data set. And I listed big data as a technology trend, even though, to be perfectly honest, I think this is mainly a shift in how we look at data. There have been technology advancements. We have new tools today for how to record and analyze and process big data sets. But big data itself is really just data. So big data itself is not a change of technology. It's more a conceptual trend. But I still find it easier to discuss it from the technology perspective. And we're really far away from realizing the full potential of big data, but there are a number of applications today, and I'll give you two examples. Big data is very prevalent in science. And for example, the particle physicists at CERN They process 1,000 terabytes of data per day. That's 1 petabyte. That's a huge amount of data to go through and process every single day. Big data is also, of course, used by insurance companies. They are collecting more and more personal profile data and claims data to build models that they use to make predictive modeling. And this can lead to very personalized premiums in the future. So how is big data going to impact testing? Well, the main challenges around big data are around recording, storing, analyzing, and curating data. And all those technical challenges, of course, translate into testing challenges. How do you test the recording? How do you test the storing? How do you test the analysis and the curation? Most of us who've done testing have at some point compared records in a database. But that's just not going to be feasible with big data. And at the same time, data integrity is as important as ever. So how do you build tests that can efficiently test big data? The other challenge is that we collect data in a different way than we used to. In the old days, we'd have a desktop machine that sat in a room and it sent data to a central server in the same building. Today, we have mobile devices, we have aerial instruments, wearable technology, and we have nanosensors. And all these different types of devices, they also collect different types of data. Not only text anymore, but sound, video, and even biometric data. I'm wearing an Apple Watch, and it's continuously collecting information about my pulse. And it's sending that to my phone, and my phone is sending it to Apple. That's a type of data collection that never existed before. And a lot of this data is being sent wirelessly. That's a whole different set of testing challenges. So the traditional example again is a desktop machine that just records text-based data. But what we have now is so many more different types of devices sending these different types of data to servers that we don't have control over anymore. So it increases the types of tests we need to run, of course, but it also presents challenges in how we test these huge amounts of data. And to be able to be a tester in a big data world, we of course need to understand data better. Most testers today, of course, have an understanding of data and data processing, but we need to go beyond that and really understand analytics and statistics and how big data works, are structured, be able to test them properly. I also think we'll need to have a much better understanding of the devices, how they work, how they collect and transmit the data. And we also need to think carefully about test environments. Most of us have struggled with getting the right data set for testing or setting up test environments. But those challenges we've experienced are nothing compared to setting up a big data test environment. Is it even going to be possible? Can you get a test data set? Will you test in production? I think those are the three pieces that are going to be really important when it comes to testing big data. As we've become able to record and analyze larger sets of data, it's also made it possible to do what's called machine learning. And machine learning is just one of many approaches to artificial intelligence. And machine learning is a way to try to mimic human behavior by having machines learn from large sets of data. So basically what we're doing is giving the computer many examples, and we let the computer build a model based on those examples or sample inputs, and then it will make predictions based on the model. So you can look at it as training the machine to learn a function f. And this function f depends on x. So if y equals f as a function of x, what we do is we provide the machine with examples of x, which are the inputs, and examples of y, which are the results. And then the machine learns how to predict y based on x. So when we give it an x, it will give us a prediction of a future value of y. So that's really the root of machine learning. And we often talk about machine learning as something futuristic, but it's of course already in use in many places. Most of us have a Facebook account or a Twitter account, and we see ads that seem very targeted to us, and it is because they are. Because machine learning is used in the background to analyze our behaviors and identify patterns and build models. And then ads are shown to us based on that model. The thing about machine learning is that it's typically a probabilistic approach. So what the machine does, of course, is that it averages the outcomes and automates that. And the biggest problem with machine learning is that it's, of course, completely dependent on the input examples. The model it builds and the prediction will be based on the data set it's given for training. So when we talk about testing in the context of machine learning, the first problem is that how do we test that predictions are correct? We don't know the underlying function. If we did that, we wouldn't have to use machine learning in the first place. So how can we test if the results is correct? The other problem is understanding how do we know that the data we provided for the learning was representative or correct? How do we know that it wasn't biased? Because we're used to testing systems that are deterministic. For a certain input, we expect a given result. And if we run the same test again, we expect the same result. Machine learning and artificial intelligence is quite different. And I think being able to test machine learning and AI will require a shift in mindset. Because there's no longer a clear relationship between cause and effect. And that's what we're used to. We're used to having that clear relationship. So there are technical challenges around testing machine learning and AI, but I think more than anything, it's a conceptual challenge. Wrapping our heads around this non-deterministic behavior. And of course, now we're seeing not only examples of machine learning and AI that we need to test, but also machine learning and AI being used in test tools. And I think that's something we're going to see much more of, is machine learning and AI becoming an integral part of also how we execute our tests. So because there's no longer a clear relationship between cause and effect, I think testing AI and using AI in testing will really require new skills and a new mindset and a well-curated data set. And those skills are, of course, going to be around machine learning technology and understanding how AIs really work. And also being able to embrace the ambiguity that comes with non-deterministic systems. Another thing that I think will have a huge impact on the future of testing is cybersecurity. And only, I believe it was yesterday, we had the big Facebook leak where somewhere between 50 and 90 million accounts were hacked and their information was leaked. And things like this happen all the time now. Big companies get hacked and user information is being stolen. Most of us know someone who's had their Instagram or Twitter or Facebook account hacked. And security has really gone from being a very specialized topic that few people really thought about or cared about, to being everyday news. We're continuously being warned about phishing attacks and scams. So it's present in our everyday conversations now, which it actually didn't used to be. And the problem is that the amount of data we're sharing and how we're sharing it is making us very vulnerable. And as testers, we are user and stakeholder advocates. And I think in the past, we were able to rely on these specialized security teams to do the testing around security. But I think that going forward, as testers, we're going to need to take more responsibility for thinking about cybersecurity risks. It's going to be a responsibility that we can't delegate to someone else. So I think there's still going to be specialized security testing teams, and they're going to have specialized tools. But I think all testers are going to need to be more aware about cybersecurity risks and raise awareness of the risks we see around security. We need to keep in mind that the software or application ecosystem has really changed. It wasn't that long ago that if you needed to do a bank transaction, you went into a bank office, you walked up to a bank teller, and they did a transaction on a banking computer inside the bank that talked directly to a bank server. And there were no other applications running on that machine than the bank applications. Today, we do banking from our smartphones. And that's the same phone that we use to play Scrabble and look at cat pictures. So really high security applications are now coexisting in the same ecosystem as very low security applications. And we need to be more aware of how those applications coexist and impact each other and where there can be potential security risks. When we talk about cybersecurity, we also need to talk about quantum computing. And quantum computing may sound like science fiction, but there are actually already commercially available quantum computers. And there's a company in Vancouver, D-Wave, where you can buy your quantum computer if you're in the need of one. So what quantum computers are really machines that are capable of running a large number of calculations simultaneously. We're not going to go into the very fascinating details of how quantum computing works. But at the core of it, it's really about being able to process a large number of calculations and complex calculations. So the immediate impact on quantum computing is on cybersecurity. Because one thing that quantum computers are really good at is to factor large numbers. And that's the foundation for almost all cryptography today. We rely on, when we're online, typically rely on large prime numbers to be behind the scenes to keep us secure. And what quantum computers can do is to factor even larger numbers than we use now. So unsurprisingly, one of the first quantum computers that D-Wave sold was a cybersecurity firm. So quantum computing, it is real and it is here. And it does pose a real threat to classical cryptography that we use today. But it also, of course, is going to introduce new types or new approaches to cryptography. But the consequence for testing is that we need to be aware that classic cryptography can no longer be considered secure. And cryptography is going to have to evolve alongside quantum computing. And we need to keep that in mind. And even though quantum computers are not necessarily commercially common yet, they are out there. And we need to change our approaches to security testing, but also to how we view security. So I've talked a little bit about big data and AI and quantum computing. And those are three, what I think, quite important future trends. But there's also ongoing trends that are not necessarily new, but are still impacting us, not only today, but I think they're also going to impact us going forward. And I want to start to talk a little bit about fragmentation. We're all familiar with the challenges around version fragmentation. It's not new, it's been around for a long time, and most of us have had to deal with it and develop approaches for it. But sometimes I doubt that we really understand how big the challenge is and how it's continuously growing. As of February last year, 97% of Android users were on one of 4 versions of the Android OS. And that doesn't sound bad at all. Almost all users only use 4 different versions of the OS. The problem is that already 3 years ago, there were 24,000 distinctly different devices. So that immediately gives us hundreds of thousands of different possible combinations to test on. So how do you select what combinations to test? You can't put them in a table and check off the most important one. You need to have a smarter approach. And it's not only picking the combinations to test on, it's also how do we test them efficiently. So again, we're talking about devices that record, store, and transmit huge amounts of data. And they do it different ways, via cellular towers, wirelessly. So we need to get better at developing approaches for testing in the fragmented world. And again, it's not only going to be which combinations we pick to test on, but how we test them. And I think in the future, testers are going to need to have a much better understanding of the different platforms themselves and the differences between different versions of the OS. I also think we're going to need new tools for better usage of existing tools to be able to increase our test coverage when we're testing devices. And that, of course, brings us into the Internet of Things. So we talk about IoT, or the Internet of Things. What we're talking about is the connectivity between physical devices, like vehicles, sensors, our Fitbits, our smart homes, etc. And last year, there were already 8.4 billion connected devices in use. That's a huge amount of devices. And everything is connected to everything else. And like we already discussed, that of course creates a large number of security vulnerabilities that we need to be able to test for. We have the challenge with the amounts of data, the big data challenge. But these devices also function differently than computers in the past, because we bring them with us. We move between being on a Wi-Fi network to being on cellular to having neither. How do we set these tests up to test what happens when there's no connectivity? How do we make sure that data is sent correctly when we're connected again? Another challenge with IoT devices is that simplicity is actually quite complex. If you pick up a Fitbit, it looks very simple. It has a minimalistic interface. There's not really a lot of buttons you can press on. And that creates 2 problems. The first one is that there's little room to provide helps and hints to the user. You can't have an F1 function that opens a help section. And at the same time, usability is more important than ever. So building in usability and testing for it is more challenging. These minimalistic user interfaces also create test constraints. We're still used to doing a lot of our testing through the UIs, but on a lot of these IoT and smart devices, it's hard to do that, or we can't do that anymore. So more and more testing will move from the front end to the back end. And that's again going to mean that we need to understand how the devices work better. We need to have a better grasp on how they function. Another challenge that we don't talk very much about, but it's becoming increasingly important, is different controls. There are more options than ever now for how to control the software that we use. And the first big step, of course, was going from the keyboard to pointing devices, the regular computer mouse. And it wasn't that long ago that we first got touchscreens. And then we get voice control like Siri. And what's happening is that the relationship between input and output is becoming less and less straightforward. We all use keyboards differently, and we use different amounts of force when we press down the keys. But with very few exceptions. If you press the letter key P on a keyboard, you're going to get a P typed on the screen or in the input field. But anyone that's ever used Alexa or Siri or anything similar on a phone knows that you don't always get the result that you expected. I've used Siri many times on my iPhone trying to send text messages, and I usually end up having to resend probably 2 out of 3 text messages. It's just not as straightforward. And if you think voice control is complicated or hard to test, there's now also emotion-based control. So it's possible to have a system that requires you to be in a specific emotional state to log in, for example. Imagine testing that. Imagine if you have to be happy 4 times in a row to be able to run a certain test. How do you put yourself in the right emotional state to run a test case? So we take these controls for granted, but we need to make sure we test them properly. And usually what we have is, of course, not only one way to control a device, but many different. And we should focus on the most commonly used one, but we can't forget about the other ones. So we talked so far about technology trends. So now it's time to talk a little bit about conceptual trends, which again is what I call an evolution of ideas. So I think that the conceptual trends are driven more by our use of or perception of technology than by technology itself. And there is a difference between how fast technology advances and how fast society changes to adapt that advancement. And autonomous vehicles and the discussions they raise, I think, is a good example of that. Sometimes the technology is ready long before society is ready to adopt it. So let's start talking a little bit about test automation. Often when we talk about the evolution and advancement of testing, what people mention is automation. And that came up in the little poll we did earlier as well. And sometimes it seems like what we're looking at or what people are picturing is that making testing better equals making testing automated. So it is implied that for testing to get better, we need to remove the humans, as if humans are so flawed that they don't really add any value to testing. And I don't think that's correct. I think humans are a very important part of testing and always will be. And I don't think that's a direction we're actually headed in. I think traditionally we had programmers or developers that wrote code, and they tested that code for the errors that they themselves could think of. I have done that myself. Then at one point, we created a tester role. And testers wrote and executed manual scripts that were based on requirements that someone else created. And then the tester role started to change. And we started talking more about quality and quality assurance and quality analysis. And testers started writing and executing both manual and automated scripts based on different inputs. And this is where we are today. And what I think we're seeing is a shift from manual testing from doing to thinking. We're starting to separate the design and the execution. And what I think is going to happen in the next decade is that we're going to see the execution of manual test cases disappear. But I think we're still going to have manual testers. And manual testers will still be creating test strategies, developing test approaches, designing tests, and exploring the software. And they're still going to be important as question askers and conveyors of information. I think that part of the role is actually going to be emphasized. What I don't think they'll do is execution of tests the way we still tend to do it today. So what I see this shift from doing to thinking be is a change of the what, how, and who of testing. So traditionally, what we test is requirements, again, created by someone else, that testers turn into test scripts. We execute the tests through manual execution, that's the how, and the who are the manual testers. The direction we've started heading in, and where I think we'll keep on going, is that the what is going to be decided through a cross-functional discussion that's facilitated by testers. Going to be multiple roles that get together to talk about what we expect the software to do. How we're going to test is going to continue being through a combination of automated scripts and manual exploratory testing. And I think it's going to be a team effort. The who is going to be a team of testers, test automation specialists, developers, and probably a lot of other roles too. At the same time, I think we see a somewhat concerning trend, which is towards specialization. Right now, we tend to think that expert is king, and that we need specialists to do certain tasks. Whereas in reality, generalists are typically better at solving problems. And we need to be conscious of this, and we need to think about it when we build up these teams. So we shouldn't put too much value on the expert. It's important to have people that has breadth of skill, and there's research that shows that cross-disciplinary learning is the best way to solve problems. And a diverse team is better at solving a problem than a homogeneous team. So, expert is king is a trend that I think we're seeing, but I'm really worried about, and one that I hope will change. What I think is also happening that might actually be a good thing is that we're sort of moving from stability to chaos. I think testing started out as being something very structured, very predictable. But we're moving away from that. And that, I think, comes through both in the conceptual trends in how we view testing and think about testing, but it's also a reflection of the technology trends, where we have machine learning that's non-deterministic, we have big data sets. We're facing challenges that we never faced before. So, taking inspiration from the Cynefin framework, that is a framework for decision making, there are 4 different states in that framework: simple, complicated, complex, and chaotic. In a simple state, you have known unknowns. So there's a clear relationship between cause and effect. If you do X, you expect Y to happen. In a complicated state, you have known unknowns. So the relationship between cause and effect, it's still there, but it's not as obvious. It requires more analysis or expertise to discern, and there's actually a range of right answers. And in a complex state, we have unknown unknowns. We can only deduce the relationship between cause and effect in retrospect, and there are no right answers anymore. And in the chaotic state, the cause and effect relationship is completely unclear, undetermined. And the reason I bring this up is because I think testing has gone through a journey from one state to the other, where we're slowly moving from stability towards chaos. So testing started out in a simple state, where there was an expected result for each test and test step. We were relying on best practices. We created manual tests based on requirements. But as our software development and use of technology got more and more complex, we moved into a complicated state, where there is still a relationship between cause and effect, but it takes more analysis and expertise to discern it. Testers need to do more thinking than doing. And I think that's where we are now in this complicated state. But then we have the introduction of big data and artificial intelligence. And I think that started to push us out of the complicated state and into a complex, or maybe even chaotic state, where the relationship between cause and effect is dissolving. And we need to be able to be comfortable giving up certainty and embrace ambiguity to handle this transition. So there are a lot of things happening. How do we best prepare for this new world of testing, the new future? No matter what the future holds, I'm sure it is going to require new skills or new applications of skills that we already have. And it's really hard to guess what they will be. And that's why I think it's, again, most important to stay curious and to continue learning. Because I do think that technology is going to continue changing very, very fast. And we're going to struggle to stay up to date, but we have to try. And we have to embrace this learning journey. And more than anything, we're going to need to be flexible and adaptable. With all that being said, I think there are some skills that are more important than others, though. And I think what all testers are going to need, and actually probably already need today, is code literacy, data literacy, and security literacy. So when I talk about code literacy, what I mean is primarily the ability to read code and maybe write simple statements. The purpose for a tester to have code literacy is to be able to read and analyze both test and production code to help create new tests, come up with test ideas, and to improve the existing code. Code literacy for me is not being able to write the actual production code, and maybe not even the test code. But code literacy also gives testers and developers a common language. Even if I, as a tester, don't know the same programming language as the developers use, knowing a programming language makes it easier for me to talk to the developers. It makes it easier to pair up and test together. And code literacy is something that all testers, it's a skill that all testers can gain. It requires, of course, having an interest and an aptitude for technology, but all testers should have that. The next skill that I think testers are going to need to improve is data literacy. And traditionally, we've already needed to understand data structures and data manipulation. But I think going forward, we're going to need to have a much better understanding of data analytics and statistics. And also distributed databases like blockchain. The data skills most testers have today, I just don't think they're quite enough, or going to be quite enough in the future. Last but not least, I think we're also going to need better security skills. So we need to increase our cybersecurity literacy. We really need to make sure that we incorporate security risks into all test design. And to be able to do that, we need to really understand application security and data security. And understand that it looks different now than it did 5 or 10 years ago. The fact that we collect so much data and share it in ways we've never shared data before changes how we have to look at security. And I've gone through these 3 skills in the order that I think they need to be gained. The most important is code literacy. And since security and data are so closely coupled, I think you need to understand data properly before you can really understand security. So, how do we prepare for this unknown future? We don't really know what we're preparing for. Well, again, I think the answer is adaptability. It's about continuous learning and a desire and a passion for continuously honing our skills. Because the context might change, but our tester skills are always going to be valuable. They're always going to be essential to the successful completion of software projects. And I think understanding and recognizing that is going to be the key success for testers. So if I were to create my testing manifesto, this is what it would look like. Questions over answers, learning over lecturing, assistance over assessment, and curiosity over fear. Don't fear the future. Don't fear that the tester roles might change. Be curious. Be curious about how technology is going to change, what new exciting things there are to learn. And as a tester, our job is to be an assistant, not to assess or judge the software we're testing. It's about assisting and making it better. We should be aware of risks and we should convey information, but we should never lecture. We should learn together with the teams we work with. We should help them learn. And we should be careful that we don't start thinking that we have the answers, but instead we should make sure that we continue asking a lot of questions. One of my favorite authors has always been Isaac Asimov, and he certainly shaped the way I view technology. And he has a wonderful quote, which is, "Your assumptions are your windows on the world. Scrub them off every once in a while or the light won't come in." And I think that's a good reminder that we need to be open-minded and we need to be curious. And the best way to prepare for the unknown is to open our minds and embrace the changes. So we reached the end of the webinar time, so I would like to ask you to do another poll for me. It's once again just a free word poll, but what did you take away from this session? What are some key words or some thoughts that are stuck in your mind? We'll see if we get any responses, or it could also be that there weren't any takeaways. Complexity. Yes, I think it is. The world is getting more and more complex, and everything is intertwined. And we're used to testing things in isolation, one product, one function. And that's just not going to be possible anymore. Excitement, I think, is a wonderful takeaway. The future is exciting. It is going to be fun, and there's so much to learn and explore. But I also agree that the human aspect of testing will always be important and valuable. Absolutely, continuous learning is key. But I also agree that we can't get away from knowing some code. Code is the basis of everything we do as software testers. And we should not be afraid of it or look down on it. So I would just like to wrap this up by asking you to, if you go back to the poll, there's also a presentation feedback where it's a short survey where you can provide some feedback on the session. It will be open once the webinar ends too. So I would really appreciate if you took a couple of minutes to give me some feedback so that I can do better. That is part of my continuous learning. With that, the webinar part is done, and I think we're going to move over to Slack. So I am going to stop sharing my screen now.
Hi again. So thank you all for participating in Future Horizons in Testing with Christin Wiedemann. As mentioned in the beginning, we hope to see you at our upcoming Contest NYC conference taking place November 14th through 16th in New York City. And we'll be moving over to Slack for the Q&A portion of this webinar, and you can find it in the events channel. Thanks again.